Hello, continuing algebra 2 gang. So today what we're going to be doing is we are going to be looking at inverses. We're going to be verifying that inverses are actually inverses, and we're going to be able to graph a function and determine if its inverse is a function. So that's what we're going to do today. These should be the notes that you have in front of you. They're only 2 pages, not too long. We'll fly by it. It'll be great. You can always pause this video if you need to take some time to copy. Oh, sorry. If you need to copy something down, pause it, copy it down, then we'll keep going. If you don't understand something, you can just move on from it. So, or you can pause it, go back, listen to it again, then move forward. So anyways, starting off here, first, we're going to tell whether the relation is a function and explain it. So looking at this here, this one looks good. So for this one, what we need to do to tell whether it's a function or not, that means the domain does not. So the domain doesn't repeat. So basically, like if I plug in 2 and I get an answer, and then I plug in 2 again and I get a different answer, then that's kind of messed up. That means that my machine of a function isn't actually working. So it's not a function. So here it seems like every input has exactly one output, which is great. So that works out. So this is a function. So yes. This one, let's say we got one here. Oh, hold up. One goes to 2 different outputs. Oh, so this one is not a function. So basically, if the domain or the input repeats or it has different outputs, then it is not a function. So that is not a function. Okay, next it says, how do you find the inverse of a relation? Well, to find the inverse of a relation, all you have to do is you swap the inputs and the outputs. That's all you have to do to find the inverse of a relation. Oh, why did that? Oh, I see what it did. Fun. Oh, there we go. Swap the inputs and the outputs. That's how you find the inverse. So for example, for this one, I could redraw it, do circles because I'm cool like that. The inverse of this would be 2, 3, -4, and -3, -1, 2, and 4. Okay, where this goes to this, -1 goes to 3, so this goes to this. 2 goes to -4, so this one will go to these 2. Okay, so basically these would be inverses of each other, but yeah, they're just inverses of each other. Okay, cool. Great. So our focus is on the relation that is a function whose inverse is a function. There's a way to test for this. So there's a couple of ways to test for this. We're going to learn the 2 ways to do it. One is algebraically with compositions of functions. And then the other way is graphically, which is you graph them and do some kind of test on the graph. But how do you find the inverse of a function? Pretty straightforward. You just follow these steps. So let's say we're given this function. First thing we need to do, switch the x and the y. The y is the same as f of x. Okay, f of x and y are the same, pretty much. So let's do that with step 1. So step 1, wherever I saw an x, I'm going to put a y. Whenever I see a f of x, I'm going to put an x. So I'm going to change it to x equals 3y minus 5. Okay, so I switch the x's and the y's. Very similar to how like I would switch the inputs and the outputs here. You do that same thing with the equation. Next, solve for y. So I'm going to just add 5 to both sides. get x plus 5 equals 3y. And then divide both sides by 3. So that means y is equal to x plus 5 over 3. So that's pretty good. So step 2, cha-ching, we got step 2 right here. Step 3, rewrite a new notation of this thing. So let's just rewrite, instead of y, we're going to write that. So the inverse function of x is equal to x plus 5 over 3. Okay, check. Oh, we forgot to check off that first one. Cool. So now step 4 says verify the functions are inverses. So in order to tell if something is an inverse, what you have to do is you have to take the composition of f and its inverse, and you'll get an answer of just x. And then same thing, but plugging it in the other way around, you should still get an answer of just x. So we're going to give that a shot right now. So let's pretend, so we have our function 3x minus 5, and we have our inverse function x plus 5 over 3. So we're going to do two things. We're going to say, so we're going to take, we're going to do this, and we're going to do this. All right, so what this says is we're gonna do the composition of the function and then the inverse function, and we'll get an answer. And then here we're gonna do the inverse function, then do the composition with the normal function. Ooh, sorry about that, I was yawning. All right, so f of x here. So we're gonna take f of x, which is 3x minus 5, and plug it in there. We're just doing what we did last couple of classes, like you guys did on your quiz. All right. And now we're going to take 3x minus 5 and we're going to plug it into our inverse function here. Not multiply it, plug it in. So we're going to replace this x here with 3x minus 5. So let's do that. So it's going to be parentheses 3x minus 5, close parentheses, plus 5 over 3. All right, so up here, what's going to happen? Well, negative 5 plus 5 is just going to give you 0. So it's going to be 3x over 3. Then 3x over, oops. Then 3x over 3 is just equal to x. Hey, check that out. So we got an answer of just x. That's what we want to see. Now, so far it's looking good that this function that we came up with is an actual inverse of this function. Okay, let's do it the other way around and see if we get the same result. So now the difference is this one, we're starting off with our inverse function. So I'm going to just write equals here. So I'm going to have f of my inverse function, x plus 5 over 3. Okay. That's a 3 there. All right, cool. Now I'm going to take all of this stuff here and I'm going to plug it into my f of x function. So I'm taking all this stuff and I'm going to replace this x with all that stuff. So it's just going to be 3 times all this stuff. And then minus 5. And we'll see what happens when we do that. So here 3 times all this stuff is just gonna, the 3 and this fraction are gonna cancel. So I'll have x plus 5 minus 5, and then x plus 5 minus 5 is just gonna leave me with x. Look at that. So I have just x here, I have just x here. So that goes to show that yes, f of x and the inverse of f of x are actually inverses of each other. If I were to plug one into the other and I would get some answer other than x, then that means that they are not, the inverse is not a function, or they're not inverses of each other. Oh, a note. So the little -1 that looks like a power isn't to be interpreted as an exponent. I know it's kind of confusing because we've just dealt with exponents, but this to the power of -1 doesn't mean it's an inverse. So don't get it twisted. All right, so let's take a look at their graphs. So inverses of nonlinear functions. So we're going to graph this thing here. What is its inverse like? Is the inverse of function. So to graph this off the top of my head, I don't think I can graph this like just freehand it. So I need to make a little table. So I'm going to make a little table here. We got X, we got Y. So I'm plugging some values. So I'm plugging 0. Actually, you know what? We're going to use the Fab 5 here. We're going to use the gold standard. So I'm going to do -2, -1, 0, 1, and 2. And we'll see what we get out when I do that. So if I plug -2 in here, -2 squared is 4. 4 plus 2 is 6. Cool. If I do -1, -1 squared is +1, plus 2 is 3. Great. Plug in 0, I get 2. Nice. Plug in 1, I get 1 squared is 1, plus 2 is 3. And then if I plug in 2, 2 squared is 4, plus 2 is 6. Okay, cool. So I end up with this. So now we can plot these points. So let's see here, -2, 1, 2, and then up 6. 1, 2, 3, 4, 5, 6, way up here. That's okay. All right, -1, 3, -1, up 3, 1, 2, 3, right here. 0, 2, right here. 1, 3, and 2, 6. Okay, look at that. So it's some type of parabola like this. Oh, except for not with that weird bend there. Try to make yours better than mine. I'm freehanding this with a mouse, so that's pretty impressive actually. All right, so what does its inverse look like? Is the inverse a function? So to find the inverse of this, I kind of already hinted at this earlier, but what I need to do is I need to swap the inputs and the outputs to find the inverse. So the inverse would look like this. So it's the same thing as above, but now my x's and y's are going to be switched. So I'm going to have 6, -2, 3, -1, 2, 0. 1 sec, I'll just do this like this. Okay, so 1 went with 3, and then we had 6. Okay, let's plot these points. So we got 6, -2. So over 6, down 1, 2. All right. That's 6, right? 1, 2, 3, 4, 5, 6. Yep. 3, -1, or yeah, 3, -1, 1, 2, 3, down 1, boom, and then this one, and then this one, and then this one. Okay. All right, check that out. It's gonna look something like that. Okay. So it's in, what do you notice about the inverse and the actual function? Maybe I'll label this as f of -1. This one as f of 1, or just f. What do you notice about these? They look the same, except for one is just like not on the y-axis, it's on the x-axis. What actually happens here is that this blue graph gets reflected about the line y equals x. It actually gets reflected across that, which is why it ends up on its side like that. So now this question, this one asks, is the inverse a function? So to test whether or not this inverse is a function using a graph, we have a couple of options. So we have the VLT and the HLT. So the VLT stands for vertical line test. I'm actually going to write this out because it's better to do that. Okay, so it's the vertical line test. And what the vertical line test does is it says if you draw a vertical line draw a vertical line and that vertical line touches the graph more than once, then it is not a function. So if you draw a vertical line and that vertical line touches the graph more than once, then it is not a function. So that means that if I draw some kind of vertical line here, so let's do the vertical line test on this thing. If I do the vertical line somewhere here and it touches it more than once, so I drew one here, how many times does it touch the graph? Only once, like right there. If I do one here, oh, it only touches it once. If I draw another one, oh, it only touches it once, right? So I drew a bunch of vertical lines, but they only touched the graph once. So that means what that means is my graph here is a function. Sweet. Let's test it out on this red one. So is this red, if I drew this line, is this a red graph a function? Well, no, because it intersects it more than once, here and here. Some people will say, oh, but Mr. Springle, couldn't I draw a line that only touches it once right there? Yes, you could, but the test says, can you draw a line in which it'll touch it in more than one place? And if you're able to, then that means that the function or the relation is not a function. Okay, so that's the vertical line test. Now the horizontal line test tells us whether the inverse is going to be a function without even having to graph the inverse. So let's write this out. We'll do this in red. So that's the horizontal line test. So if you draw a horizontal line and that horizontal line touches the graph more than once, then its inverse is not a function. Okay, so if you draw a horizontal line and that horizontal line touches the graph more than once, then its inverse is not a function. So what that's saying is if I'm able to draw a horizontal line anywhere and it touches it more than once, like here it touches it twice, then that means its inverse, which is this, is not a function. And that holds true, right? We just tested using the vertical line test if this is a function or not, and it's not a function. So the horizontal line test lets you know immediately, without having to graph this other thing, that its inverse is not going to be a function. Okay. Cool. So you're going to have some examples from your homework. So one example would be like this one here. Find the inverse of the function. So to find the inverse of that function, let's go green. So to find the inverse of this function here, you got to just do what we said above in these 4 steps here. So step 1, swap the x's and the y's. So we're going to replace all the x's with y's and the f of x with x. So we're going to just have x equals 2y to the power of 3 minus 6 over 9. So solve this for y. So multiply both sides by 9. So we got 9x equals 2y to the power of 3 minus 6. Add 6 to both sides. Divide by 2. 9x plus 6 over 2 equals y to the power of 3. And then from there, you can cube root both sides. So to the power of 3, to the power of 3, and that'll undo that. So you'll just have y equals the cubed root of 9x plus 6 over 2. There you go. This is the inverse of this. Now, if we're going to verify that this is the inverse of this, we got to do f of the inverse of x. Oof. And we got to do the inverse of f of x. So we have to do it both ways. So we have to do the composition both ways. So to do that, we're going to take our inverse function, plug that in here. So cube root 9x plus 6. And then take all of this and plug it into this function. So we're going to have 2 times all this. Power of 3 minus 6 over 9. See what happens here. So the cube root and cubing it are going to cancel. So that cancel. And then I'm going to multiply. So I guess I'll write that out. So it'll be 2 times 9x plus 6 over 2 minus 6 over 9. That and that cancel. So I'll have 9x plus 6 minus 6 over 9. The 6's cancel. 9x divided by 9 cancels, and I'll just be left with x. So far, that way works. Now we got to do it the other way. So now we're going to start with our original function. So we're going to have f inverse of this stuff. We're going to take all this stuff and plug it into our inverse function. So we're going to have a big cube root times 9 times all this stuff. Plus 6. Oop, I'm good. Yep, I'm good. All right. So when I multiply, these 9s are going to cancel. So this is going to be 2x power of 3 minus 6 plus 6 over 2. These 6's are going to cancel out. So I'll be left with 2x power of 3 over 2. The 2's are going to cancel, and I'll just have cube root of x cubed, which is just going to leave me with x. So I got x both times. So that means that this has an inverse, and its inverse is this. So these two are inverses of each other, because when we did the composition of them and their inverse, we get x both times. Okay. And then you might have a problem like this where it says, all right, well, given a graph, what's going to be the inverse of this function? So there's two real ways that you can, like, I guess, think of this. You can think of the line y equals x and try to, what I would do is, if I would come up with the equation of this line, which is just going to be, what's that y-intercept? 1, 2, 3, 4. So it's going to be y equals, what's the slope? 1, 2, 3, 1, 2. So it's going to be 2 over 3x minus, what's that? 1, 2, 3, 1, 2, 3, 4. So this is my function. So to find the inverse, I just got to swap the x and the y's. So it's going to be x equals 2/3 y minus 4. I'm going to add 4 to both sides. So x plus 4 equals 2/3 y. And then, oh man, I'm running out of room going over here. So then I got to do multiply both sides by 3/2. Because 2/3 and 3/2 are opposite reciprocal, or they're just reciprocals and they'll cancel each other out when you multiply them together. So then I'll have 3/2 x plus 4 times 3 is going to be 12. 12 divided by 2 is 6. So that's going to be my answer. So that means that B is our solution. Okay, well, that's all our notes. It's pretty short. We only got 2 pages here. So give your homework a shot. Your homework is going to be this. I'll make sure I upload it onto Google Classroom. You guys will have until I get back to do this homework and go through these notes. All right. Thank you all for paying attention and watching this, and I will see you all when I get back. Bye.